Hey everyone, and welcome to This Explainer. Today we're going to dive into a 500-year-old mathematical mystery that, honestly, still manages to trick almost everyone who tries it. You know how some of the oldest puzzles in human history are the ones that continue to stump us the most? We have all this modern technology, yet a simple riddle from 5 centuries ago can completely tie our brains in knots. Today we're looking at a classic legend, a story of royal inheritance that contains a hidden math puzzle so clever it completely bypasses our normal way of problem solving. We're going to lay out the facts, break down the logic together, and see if we can outsmart a 500-year-old king.
If you think you've got a sharp, logical mind, this is absolutely the perfect test for you. But be warned, it requires a very specific way of thinking. The quote goes, "Most people solve this 500-year-old puzzle incorrectly today. Can you solve it in 30 seconds?" Now, the reason that time limit is so intimidating is that when we're rushed, our brains just naturally default to standard, linear patterns. We try to use brute force. We try to guess a number, run it through the formula, see if it works, and if it doesn't, we guess another number. But you simply cannot do that in 30 seconds. You have to find the trick.
Section 1. The Story. A King's Final Test. Our mystery begins with a dying king of a vast empire who wanted to test the intelligence of his 3 sons before passing on his immense fortune. He ordered his most trusted minister to divide the royal treasure using a really specific, repetitive rule for each of his 3 heirs, and the rule was exactly the same for all of them. Step 1. The first son steps up to the royal vault and thinks exactly half of the gold coins inside plus 1 extra coin. Step 2. The second son steps up to whatever is left over, takes exactly half of those remaining coins plus 1 extra coin. And finally, step 3, the third son steps up to whatever is left after that and thinks exactly half of those remaining coins plus 1 extra coin. It sounds kind of confusing at first, but it's really just a rigid mathematical formula. Half plus 1, half plus 1, half plus 1.
So, the minister followed this bizarre rule perfectly. He executed the king's instructions to the letter. But astonishingly, right after the third son took his share, the treasure vault was left with absolutely 0 coins. Nothing. Not a single gold piece remained in the vault. The entire fortune was distributed flawlessly among the 3 sons without breaking a single coin in half. The division was perfect, and the vault was utterly empty.
Section 2. The Challenge. No pen, no paper. So the crucial point is, based strictly on the minister's actions, how many gold coins were in the treasure vault at the very beginning?
Now, before you rush to start calculating, just pause for a second. Without calculators or paper, most people fall right into the trap of trying to guess the starting number and working forward. This is actually why 90% of people make the exact same mistake. They start from the beginning. It's our human instinct, right? We're chronological. We want to say, okay, let's pretend there were 100 coins. Son 1 takes 50 plus 1, so 51. That leaves 49. And boom, immediately you're dealing with odd numbers, fractions, and a messy mental calculation that just totally falls apart. You'll literally exhaust yourself guessing random starting numbers.
To crack this case like a true detective, we have to abandon our usual habits and completely reverse engineer the timeline, because real players think from the end. If you want to solve a problem that results in 0, the absolute best place to start your investigation is at that 0. We have to flip the script. Instead of asking what the first son took, we need to ask what the last son did. By changing our perspective from chronological to reverse chronological, a nearly impossible mental math problem suddenly becomes remarkably simple.
Section 3. The Reveal. Working backwards. Okay, let's dive into this and build the math backwards, starting with the exact moment the vault was emptied. We know the third son left nothing behind, which means he must have walked up to a vault containing exactly 2 coins. Think about it. After son 3, there are 0 coins. His rule was to take half the coins plus 1 extra. So for him to take half plus 1 and leave 0, he must have been looking at 2 coins. Why? Well, because half of 2 is 1, and if he takes 1 extra, that's 1 plus 1, which equals 2. He took 2 coins from a pile of 2 coins, leaving exactly 0. It's perfectly neat. So we now definitively know that before the third son walked in, there were exactly 2 coins sitting in the vault.
Now, what's really fascinating here is that this number 2 becomes the exact remaining balance that the second son left behind. By solving for the third son, we've just created our starting point for the second son. That's the beauty of reverse engineering. The end of one sequence is the beginning of the previous one. We're essentially walking backward through time. The second son walked away, and the vault had 2 coins sitting there just waiting for the third son.
Applying that exact same reverse logic, we can deduce that before the second son took his cut, the vault must have held 6 coins. Let's verify this. Son 2 left 2 coins. Let's test the number 6. If he walked into a vault with 6 coins, he'd take half of 6, which is 3. Then he takes 1 extra coin, making his total haul 4 coins. If he takes 4 coins out of the 6 he started with, 6 minus 4 leaves exactly 2 coins. And that perfectly matches our timeline. So before the second sun even touched anything, the treasure chest contains 6 coins.
Look at that. We are successfully working our way right up the chain, identifying that the first sun must have left exactly 6 coins in the vault. Do you see how fast this moves once you stop guessing and start reverse engineering? We're already 2/3 of the way through the puzzle, and we haven't even needed to write a single thing down. The math is simple as long as the framework is correct. The first sun finishes his turn, he walks away, and the vault contains 6 coins.
Finally, to leave those 6 coins for the second sun, the very first sun must have been looking at a grand total of 14 coins. Let's verify this final step. Sun 1 left 6 coins behind. Let's assume he started with 14. He takes half of 14, which is 7. He takes 1 extra coin, which brings his total to 8. If he takes 8 coins out of the original 14, 14 minus 8 leaves exactly 6 coins. It works flawlessly. The math checks out at every single stage.
And this brilliantly illustrates the entire chronological timeline, proving our math is absolutely flawless. Let's run through it from the beginning. The vault starts with 14. Sun 1 takes 8, leaving 6. The vault now has 6. Sun 2 takes 4, leaving 2. The vault now has 2. Sun 3 takes 2, leaving absolutely 0. Reading it forward like this, it seems almost like magic how perfectly it resolves to 0 without any messy fractions. But as we know, the magic is just the result of excellent backward logic.
The answer to our 500-year-old mystery is 14 gold coins, proving that lateral thinking and reverse engineering are incredibly powerful tools. What I love most about this puzzle is that the number 14 isn't even incredibly large. It's not some massive million-coin fortune. The trick wasn't the scale of the wealth. The trick was the process. The king was testing to see if his sons could look at a problem from the destination backwards to the origin. In life, business, and strategy, sometimes the only way to figure out where to start is to clearly define where you want to end up.
Section 4. One more riddle. The 4-sun scenario. Before we wrap up this explainer, let's take this newfound mental framework and push it just one step further.
Here's the question for you. If the king had 4 sons, and every single son used the exact same rule, half the remaining coins plus 1 extra, leading to a perfectly empty vault at the end, how many coins must have been in the treasure at the very start? Use the reverse engineering technique we just learned, calculate the answer, and definitely drop your solution in the comments below. Don't overthink it, just trust the backward process. I seriously can't wait to see who gets it right. Thanks so much for joining me on this explainer, and keep thinking backwards.